In this example, we are given the impulse response of an LTI system, and we are asked to determine whether the system is memoryless or with memory, stable or unstable, causal or non-causal. One mistake that many students make is that they confuse this type of question with the earlier problems where we are given the input-output equation of a system and asked to determine those 6 properties. In those problems, we had to check whether the system was linear, time invariant, invertible, stable, causal, or memoryless. We already discussed that in another video, and you can find the link above. But in this example, we are given the impulse response of an LTI system, and based on that impulse response, we need to decide whether the system is stable or unstable, causal or non-causal, and whether it has memory or is memoryless. First, let's talk about the memory property. We know that an LTI system is memoryless if Hn is equal to 0 for all n not equal to 0. So if this condition is satisfied, then the system is memoryless. Now for the given system, let's substitute n equal 3 as an example. We get H3 equals 1/3 to the power of 1 multiplied by U4. Let me quickly remind you about the unit step function, which we also explained in another video and whose link is available above. The unit step function is equal to 1 for positive values of n and equal to 0 for negative values of n. So, here U4 is equal to 1 and the result becomes 1/3. Notice that at n equal 3, the impulse response is not 0. Since there exists a time instant where Hn is non-zero for n not equal to 0, the system is with memory. Now let's move on to causality. We said that for an LTI system to be causal, Hn must be equal to 0 for all negative values of n. If Hn equals 0 for all negative n, then the system is causal. Now let's substitute n equals -1. We get h minus 1 equals 1/3 to the power of -3 multiplied by u0. Now 1/3 to the power of -3 becomes 27. And from the definition of the unit step function, u0 is equal to 1. So the result is 27. This means that h of -1 is not 0. Therefore, the system cannot be causal and we call it non-causal. Now let's discuss stability. For an LTI system with impulse response Hn, the system is stable if the summation of the absolute value of Hn from -infinity to positive infinity converts to a finite value. Since Hn in this example is real and positive, the absolute value is the same as the function itself. So we can write sigma from -infinity to positive infinity of 1/3 to the power of n multiplied by 1/3 to the power of -2 multiplied by u n plus 1. Now this constant term 1/3 to the power of -2 can be taken outside the summation. And since 1/3 to the power of minus 2 is equal to 9, we have 9 multiplied by sigma of 1/3 to the power of n multiplied by u n plus 1. Now pay attention to un plus 1. This is simply the unit step function shifted 1 unit to the left. That means it becomes 1 starting from n equals minus 1. And before that, it is 0. So instead of starting the summation from minus infinity, we can start from n equals minus 1. Therefore, the summation becomes sigma from minus 1 to positive infinity of 1/3 to the power of n. Now let's expand the first term. At n equals minus 1, 1/3 to the power of minus 1 equals 3. So we get 9 multiplied by 3 plus sigma from 0 to positive infinity of 1/3 to the power of n. Now we use a well-known mathematical formula. Sigma of a to the power of k from k equals 0 to positive infinity is equal to 1 divided by 1 minus a. Here a equals 1/3. So the infinite series becomes 1 divided by 1 minus 1/3, which simplifies to 3/2. Finally, the total result becomes 9 multiplied by 3 plus 3/2, which is a finite value. Since the summation converts to a finite number, the system is stable. So in conclusion, this system is with memory, is non-causal, and is stable. In this example, we analyzed 3 important properties of an LTI system using its impulse response. We have many similar videos on our channel. So if this video was helpful for you, please subscribe to the channel and check out our other videos as well.